Morning. This lesson that we're going to talk about today is on solving proportions. And we're going to look at two methods for solving proportions today. And they're really using the same concept. They're just going to look different. And the biggest thing is that the first one has some limitations in how easy it is based on what your fractions are, what your proportions are. And the second one is one that always works. Like absolutely no matter what, you can always use the second method and you don't, again, they're very similar. They're using the same concepts. That's how math is. Just when we look at it in a different way, sometimes it makes it easier. So the second method might seem a little bit harder in that you'll probably want to use your calculator and you might have some issues remembering what to do. But once you have it, it works every time you need to solve a proportion. And so we're going to have some problems later in the week, like word problems using proportions, that you'll really want to understand method 2 for. But method 1 is a great way to start. So, proportion, okay, remember 2 ratios that show proportion are equal. So if I have 2 fractions that are equal to each other, that's showing a proportion. So we solve proportions when we have 3 pieces of information and we're missing the 4th quantity. Okay? That's the key. Solving a proportion means that there's a piece of information missing, and it can only be one. We have to have 3 pieces of information. We can't solve for 2 unknown amounts. That doesn't work until you get further along in algebra and you're given more information. But those problems are a lot more challenging. So, a proportion requires 4 pieces, 4 numbers. If you're given 3, you can solve a proportion and find the 4th number. So that's what we're going to do. So method 1 is really similar to what we do when we're trying to get a common denominator. When we're adding and subtracting fractions and we need a common denominator. Very, very similar. So, and it doesn't matter which way you look, because remember, equality goes both ways. So 2/3 equals 20 over n, but 20 over n also equals 2/3. So you can do your work either way. Like, I'll show you what I mean. So here in this one, I want to know if 2 has something, if 2 has something multiplied or divided by it to give us 20, then 3 is going to have the exact same thing multiplied or divided by it to get whatever n is. So, Logan, stop. Sorry, this is real life. So, remember, when we are getting common denominators, we're really just multiplying by a fancy 1. But you can also divide by a fancy 1, because multiplying by 1 and dividing 1 don't change a number. They just change the way it looks. So, if you look between 2 and 20, obviously 2 is being multiplied by a number to get 20, because 20 is bigger. So if I think of what fancy 1, sorry, my 1 looks really bad today. If I think of what fancy 1 would I multiply by to go from 2 to 20, that's 10 over 10. 10 times 2 is 20, and 10 times 3 is 30. So in this example, n equals 30, because I multiplied this by 10, and I multiplied the 3 times 10. Okay? Now, look at the difference in this example. This fraction, this ratio, the numbers are larger than they are over here. So I can do this 2 ways. I can either think of what do I divide 36 by to get 18? Because that's my number that I'm looking at. I can't use 42 because I don't know what happened to 42 to get n. but I can look at what happened to 36 to get 18. But I can also look at what happened to 18 to get 36. So whichever way is easier for you, it doesn't matter. I like multiplying more than I like dividing. That's just, for me, that's the way that my mind works better. I prefer to multiply. So if I give myself my little fancy 1 over here that I'm going to multiply by, what do I multiply by 18 to get 36? 2. 2 times 18 is 36. And so that means I have to multiply the top by 2 also. Just like when I'm changing a fraction to get a new denominator, I have to multiply the top and the bottom by the same exact number because I'm multiplying by 1. And multiplying by 1 does not change my number. It just changes the way it looks. So 2 times n is 42. So what do I multiply by 2 to get 42? That would be 21. Now, I'm going to show you the same one looking the other way. I could also say, what do I divide by? What do I divide 36 by to get 18? Remember, I'm going straight across because I'm thinking, how do I go from this denominator to this denominator? So what would I divide? If I want to divide by a fancy one, I would have to do 36 divided by 2 and 42 divided by 2. 36 divided by 2 is 18. 42 divided by 2 is 21. So again, you get to pick which way you look at it. As long as you are following the rules, it doesn't matter which way you choose to do it. Okay, so here, notice my missing number is in the left-hand side. It doesn't matter. They're equal. So remember, equality, it doesn't matter which way you look at it. If I say this number is equal to this number is equal to this number. It doesn't matter which way you look at it. So if 12 over n equals 1 over 3, look at my numbers that are across from each other. What do I do to 12 to get 1? Well, I can't multiply because 1 is smaller, so I'm going to divide. Oh, I think I do 12 divided by 12 to get 1. So that means that n divided by 12 is 3. That's harder for me to think of. If that's harder for you to think of, switch it around. 1 times 12 is 12. 3 times 12 is 36. So you pick if you want to do it this way and get these numbers, or if you want to do it this way and you're getting these numbers. I don't do both other than to check, but feel free to look at it either way. So you can check them in your head to make sure it works both ways, but you don't need to write both things down. Because technically, what I have written down now isn't true. 12 divided by 2 does not equal 1 times 12. Or 12 divided by 12. Because 12 divided by 12 is 1, and 1 times 12 is 12. And so with both of these written here, I've created something that's false. That's just me being nitpicky because I don't like to say that two things are equal if they're not. So if I'm just looking at that, that's correct. Dividing by 12 or multiplying by 12. One or the other. Okay, now in this last example here, I am going from 90 to n and from 100 to 20. So how many 20s go into 100? That's 5. So that means that this was divided by 5, so that means I need to do 90 divided by 5. I don't mind if you use your calculator, so you don't even have to ask anymore. When we start math in 7th grade, there will be some things we do where I say no calculators allowed, like when we're working on our fractions and things like that at the beginning. And then after that, when we get certain concepts down, then I say, use your calculator, because we don't need to spend a lot of time on arithmetic when we're looking at bigger math concepts. You've learned how to do the arithmetic, so now we save time by not doing it by hand. But it is so important that you learned how to do it. So don't say, why didn't we always get to use a calculator? Because you have to know how to do it. Somebody has to still know how to make a calculator. You can't make a calculator if you don't know how it works. And you might not have one around sometime. You might find that a lot of times it's faster not to use a calculator. That's something I try to teach the junior high kids all the time because they use their calculators, and you can start to get lazy about it because you think it's faster or easier when a lot of times it's not. So, anyway, I'm not going to spend time on figuring this out today. I'm going to use my calculator. 90 divided by 5 is 18. So, n equals 18. I use this particular proportion all the time because we have 20 words. Well, not right now because we aren't doing spelling tests, but we have 20 words on our spelling list. And so if you miss 2, you get 18, which means you have 90%, 90 out of 100. And we'll be looking at that later this week at percents. But I can look at a spelling test score now out of 20 and know exactly what the percent is because I use this proportion in my head. So it makes my life a little bit easier. It's harder when there are 27 problems that you're figuring out a percentage for. But this one's really handy. Okay. Hopefully you've noticed here that method 1 is for proportions that have a whole number being multiplied or divided. Okay? Whole numbers. Times 2 divided by 2. Times 10 or divided by 10. Times 12. Times 5 divided by 5. Whole numbers. Okay? Just like when we change a denominator. We don't like change the denominator like, I'm going to multiply both of them by 1.5. Like we don't do that. So whole numbers. And that's why method 1 is good for that, but it's not perfect because it's not always the easiest way to do it. So now we're going to look at the method that always, always, always works. Absolutely no matter what. I'll even show you with those easy ones. So method 2, this is for worksheet B. You use the cross product rule, which we've talked about. The cross product rule, it says that if 2 ratios are equal, if I have a proportion, then these cross products, the numbers at diagonals, when I multiply them, A times D, that equals C times B, or B times C, whichever way you want to look at it. So those are my cross products. So I use this concept to solve a proportion, because if I know 3 of those numbers, I can find this third one by multiplying these 2 and dividing by this one. Or if I know these 3 and I'm trying to find this one, I can multiply these 2 and divide by this. Now this might look scary to you, but this is me showing you how this works. Now I'm going to show you how we apply it, and it's a lot easier. Okay, so you'll have your proportion, you'll have a missing number. Okay, you multiply the 2 numbers that are at a diagonal to each other. So like if I don't know what C is, I'm going to multiply A times D, because there are going to be 2 numbers that I know that are opposite each other. So I multiply those. If I don't know A, then I'm going to multiply these 2, because I don't know what A is, so I can't multiply it yet. Okay, so you multiply the 2 numbers that are at a diagonal to each other, and then you divide by the third number. And that's it. And then you'll round your answer. Okay? So let's look at those, because I know sometimes it's harder to understand without seeing it. Okay. So I have 9/10 equals n over 25. I can't multiply 10 by a whole number and get 25. Okay? 10 doesn't go into 25. So my method in the beginning isn't super helpful now. I would have to multiply by a fraction or a decimal number. And I don't want to do that. So 9 and 25 are my two numbers at a diagonal that I know. Not these two, because I don't know n. Okay, so I'm going to multiply those. So I'm going to go 9 times 25, and then I'm going to divide it by 10. Okay, multiply the numbers that are diagonal, divide by the other number. Okay, so on my calculator here, I'm going to go 9 times 25 divided by 10. You can do it all at once. Okay, you don't have to do it in steps. N equals 22.5. It's already rounded for me. I want to round to the tenths place. It's already there. So I'm good. So this is my answer. So that means that that n is that 22.5. Okay, here, these two are at a diagonal, not 3 and n, because I don't know n, so I can't multiply those yet. I can multiply the diagonal numbers that I know. So I will do that. So 29 times 53. And then I'm going to divide that by the third number, 3. And I'm using my calculator because I don't need to spend the time doing all of that. Now this one, I have to round because I get 512.3 repeating. You could put 0.3 repeating if you'd like to, or you could just write 512.3 because you were told to round it to the nearest tenth. So that is just as accurate. Okay, here I'm missing this number in the top left, so I'm going to multiply these two because these are the ones I know. Oh, that's got a decimal. I don't care if it has a decimal because I'm going to use my calculator. I'm going to follow the rule. It doesn't mean anything different. So I'm going to multiply those two numbers that are across from each other, and then I'm going to divide by 162. Aren't you glad I'm letting you use your calculator for this? 12.5 times 75 divided by 162 equals, so n equals 5 and then if you look here, it's 5.787. So 5.78 means I'm going to round that, I'm going to round to an 8 here. Okay, look here, that 7 has an 8 next to it. That's going to bump my 7 up to an 8. So that's closer to like $5.80 than it is to $5.70. If you think of it as money. Money always helps me to think of math. Okay. My last one. I know that 42 and 7 are diagonals, and I know what they are. I can't multiply these first because I don't know what n is. So you're always looking at the two diagonal numbers that are there. Okay. And I'm going to multiply those. 42 times 7 divided by 3. 42 times 7 divided by 3 equals, n equals 98. This one I don't have to round because this one really has whole numbers. If you look at 42 divided by 3, that's 14. So really what I did here is, if I was looking at it like method 1, it's kind of like I multiplied these by 14 over 14. Well, let's see if that makes sense here. What's 7 times 14? I really hope it's 98. And it is. See how that 7 times 14 is also 98. These work exactly the same way. It's following the same principles. It just looks different. And so that's hopefully helpful to you. Remember, method 2 will always, 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 always work. And when you have a calculator, that makes it's super slick to just multiply your two diagonal numbers and divide by the third. Okay, so today's assignment is to do worksheet A. Worksheet A, where you can use method 1. Okay, and method 1 is really easy with worksheet A. You can use your calculators for it too. If you're stuck on something. Some of the numbers are kind of big. And then you need to use method 2 on worksheet B because they're not going to be whole numbers when you're changing in between. Okay, so Do your best on those. Your parents have the answers in an email so they can check it for you. All right? And I will see you for our next lesson. I miss you guys.